Azure. How's it going? All right, woo! That's right. Some of the people who cheered weren't even on my team. But no, thank you for coming to this talk about scaling Kubernetes securely and reliably with the Azure Kubernetes Service. I'm Brendan Burns. I'm a CVP for Azure Cloud Native Management and open source and Linux on Azure, and I'm really excited to have the opportunity to present this with a couple other folks from my team. I wanted to start with something that I think is hopefully not super controversial to folks in this audience, which is that Kubernetes is the infrastructure for AI and modern applications. So whether you're looking at the latest startups or enterprises that are adopting AI, looking to modernize their applications, they're doing it on top of Kubernetes. It's also the foundation for a lot of the people who are building foundation models to develop the things that they are doing. And it is used for being scalable and portable throughout all of the AI stack. The portability is an especially important one. I know that we're all sort of on the hunt for GPUs wherever we can possibly find them. And so the ability to run your workload in a variety of different environments, whether it's on-premise, in the public cloud, in other opportunities in other clouds, having that portability is critical. But also being able to scale to meet, if you go hockey stick and go viral, or you have major diurnal patterns where you scale up and scale down, having that ability to scale is really important as well. I was also, just recently talking to one of the startups that has emerged in the open source AI ecosystem, and of course, Kubernetes provides the platform on which the open source AI ecosystem is being built as well. And when we look at Azure Kubernetes Service, you can see that we've had a whole bunch of features and functionalities that make it possible to build that scalable AI platform on Kubernetes, on Azure. So we have integration. We form sort of the bridge, I guess I would say, for the Azure Kubernetes Service. We form a bridge between the Azure ecosystem with capabilities like Entra ID and workload identity into your cluster, as well as the open source ecosystem, where we're both contributing to existing open source projects as well as creating new open source projects for you to have abilities. Additionally, we're excited about all of the other capabilities that we bring to this bridge with things like AKS Anywhere that allows you to do learning on-prem where a customer's data might be, reliability and performance and taking care of security and all of the aspects of operationalizing this relatively complicated piece of software. These are all really critical things that we can deliver as we form that bridge between the Azure ecosystem and the open ecosystem. And it's not just you as customers, I think, who are adopting this solution. What we're seeing is that Microsoft itself is running AKS at scale, whether that's your interactions with ChatGPT, whether that's interactions with Office, Teams, Xbox, one of my personal favorites, or GitHub Copilot. These are all things that are being modernized and delivered with AI on the back of the Azure Kubernetes Service. And so with that, I wanted to introduce Durga, who's going to talk about how we're powering Microsoft 365 at scale with the Azure Kubernetes Service. There you go.
Brendan. Hello, everyone. I'm Durga from the M365 platform. Over the past, M365 platform, as you know, powers critical end-user experiences like Copilot, Teams, Exchange, across global Azure data centers across the world. It runs on hyperscale cloud infrastructure with millions of cores across the globe. Over the past few years, we've been aligning this massive platform with Azure Cloud. In fact, today, we are one of the largest tenants on AKS. So why did we choose AKS, and why did we choose Kubernetes? Running a large set of services at Microsoft scale means teams often do the same repeating work and solving similar problems like patching, deployment, monitoring, and enforcing security standards over and over. This duplication leads to inefficiencies, inconsistent practices, and increased operational overhead. Kubernetes gave us a clear path to standardize and streamline these operations. It drives efficiency through centralized orchestration, enforces common patterns like deployments, load balancing, scaling. So every service adheres to these principles out of the box. Containers are the foundational blocks to enable consistent deployment across environments. They provide strong isolation, which is required for our workloads, and create opportunities to standardize application delivery and operational practices. But Kubernetes alone is not good enough for us because we needed a managed solution. We didn't want to manage control plane, manage integrations with open sources, like that. So AKS, we choose as the backbone for our container strategy. It delivers cross-platform with Windows and Linux mix. We have a good number of services that operate both on Windows and Linux. It is resilient, fully managed control plane, makes sure that all our services are running at scale. It removes the operational overhead so that we don't need to maintain the AKS upgrades and all of that. In short, Kubernetes gave us the framework, containers gave us the consistency, and AKS gave us the enterprise platform to run at massive scale. So in scale terms, we run tens of millions of pods hosted on hundreds of thousands of nodes and thousands of clusters across all Azure regions and in every cloud. We run on, as I said, we run with Windows and Linux mix. So how do we organize our fleet? We follow few key principles. The first one is we use per service isolation model to ensure each service is deployed independently. But one cluster isn't enough for our service scale. We treat every cluster as a failure domain, essentially as a unit of deployment. Each service is deployed to many clusters. So in fact, if a single service can span hundreds of Kubernetes clusters to support scale and to provide isolation. If one cluster has an issue, a fraction of the service is only affected. The third principle, we use managed safe deployment practices. These are enforced from out of the box. They're built into the containers, they're built into the pods and our nodes. Fourth, we standardize config deployment across regions and clouds. So essentially, our developers define the containers once. We take the same container and deploy in every cloud region across the world. So when you add it all up, across all Microsoft 365, we have tens of thousands of services deployed worldwide. So with adoption of Azure Kubernetes at scale, we unlocked a number of efficiencies. Common tool chains, for example, boost our developer productivity and reduce the learning curve. At the scale we run this adds up pretty quickly. Safety is built in starting from the deployment phases with standardized probes, pod disruption budget, and staged rollouts built into the deployment pipelines. New service onboarding is also easy because now our developers don't need to worry about how they deploy it, how they standardize it. New regions bring up. Whenever we build new regions or new cloud, it's just a rinse and repeat operation because all we need to do is ensure the new configuration is set up, and then we deploy. With this, agility for the developers is one. The second one is how do we make sure that runtime experiences are uniform, they're consistent, and they stay consistent across the board. We have standardized every service, how it is deployed, eliminating custom tools and manual process. This means we have the same proven automated pipelines which reduce risk and boost reliability. Safety is built in. Every deployment benefits from gradual rollouts, integrated health monitoring. Engineers don't have to worry about the critical step. The platform enforces the best practices by default. Policy and compliance are enforced globally. Centralized controls ensure every workload meets our security and operational standards. Real-time telemetry is integrated into the pipelines so that If something happens, the pipelines halt the deployment. They have an opportunity to roll back before blasting into the whole regions. Leveraging AKS enables us with fast release trains. We use node pool snapshots, which was a typical problem for us because our environment is so big. We used to start with one version of Windows, but then by the time we reached towards the tail end, the Windows version used to change. So node pool snapshots allowed us to do that. And many of our services, they run worldwide, right? Some are in diurnal patterns. So we choose maintenance windows. So one service gets upgraded. For example, services running in Europe, they get upgraded during non-peak hours. Same patterns we use across the board to maintain our services. So how did we do this? Migrating, as you might all experience at some point, migration is a big pain, right? Very large services, migrating large services, particularly many of these services are live, they're running, they're taking real traffic. We can't just say, hey, you shut down for a day and move it to Kubernetes, right? So this happened over the past 3-4 years. We migrated them slowly, one by one. But the thing we recognized earlier when we were migrating is it's not a typical lift and shift. You can't just take code that is running as a Windows service, move it to container, right? So that's one huge learning we had. The second learning is many of the services are built on Windows, and we are used to deploying these as VMs in Azure. So undoing the learning where a VM is not equivalent to a pod, that took us some learning both for the platform engineers and for the service engineers. The other key problem when majority of the services came from Windows Service to the container networking world is networking, right? Container networking is different than your normal Windows networking. So we had to take care of many things when the services are onboarding, like SNAT port management, IP address allocations, all of those things, we had to take it. But over the period, we learned from them. We incorporated those into our learning so that we get started in a good state from the beginning. So ultimately we moved all the workloads into AKS. They're all running on AKS now. And this is laying down the foundation so that our service engineers don't need to think about maintenance and all of this. They just think about new features they want to enable. Observability at scale, metrics collection, we have huge number of metrics across number of clusters we run. So we use Prometheus rules for Grafana. We use Grafana as a front end, and we use headlamp as a single pane of glass for real-time observabilities. Security is foundational for M365 platform. We need layered defenses. We need defense in depth across all the stack, going from the pods to the nodes to the networking. So for that, we choose cluster as a security boundary. We operate with least privileges by default. And we use Azure policy and gatekeepers for enforcement. So overall, M365 runs mission-critical services at hyperscale on AKS. Our operation model is reproducible. Everyone, we did it, so you can do it. And at our scale, the way we operate, there were so many learnings from M365 platform that are incorporated into the Kubernetes features now. So hopefully you all will know more about it. So I'll hand it over to George to walk you through what's new in AKS.
Thanks, Durga. You can't really overstate the importance and the value how much we value this partnership with the folks at M365. The learnings we got were absolutely invaluable. And it's based on a lot of those learnings that we are announcing a lot of things today, not just from M365, but also from all of you that are using AKS in the room and at home as well. Operating at scale, as you've seen from Durga, throughout their migration, as well as the way that they operate, has a number of challenges, from reliability, capacity, observability, how to do safe rollouts, how to do configuration management, how to have a platform that is engineered for productivity, that is focused on your developers, and that gives them the productivity that they need. Have multi-cluster kind of management consistency, because you might have a heterogeneous environment and you might need that consistency. And how to have mission-critical performance that adjusts to your business needs, as well as the security that is hardened for your compliance requirements. And finally, something that is very, very important to all of you in this room, I'm sure, which is to maximize the efficiency of your operations, of your infrastructure, to reduce the cost of operating at scale. I'm going to go and talk a little bit about the AKS capabilities on these areas. To be honest, we could have a whole day presentation on all of these categories, so I'm not going to talk about all of the AKS capabilities. I'm also not even going to cover all the announcements we have. There are several sessions that I definitely recommend you to take a look that we'll cover at the end to go across some of the different areas. But there is one thing that I want to start with, which is there are really two operating models in AKS today. You might have heard or not. If not, I hope you can take this time to learn about it, because you have the standard operating model. That's how AKS got created. And it's a model where you really are able to bring your own opinions, build your own story, put it together, bring everything from open source world, anything from third-party vendors. And Microsoft provides a platform and a baseline for it. There's also a new operating model, which is for folks that maybe are not that interested. Maybe they don't have opinions. Maybe they actually are seeking it for us to create that paved path. That is what automatic operating model brings you. That has Microsoft's fully opinionated approach to running Kubernetes at scale and in production. These two models are not necessarily incompatible, but you do need to pick one, but it's not an all or nothing. You can transition between them. So if you happen to like 90% of our opinions, you can start with automatic and then transition to standard and do the tweaks that you might want. There's nothing that you lose. The features, we're not trying to gatekeep them between the two services. These are not two services. It's the same single service, the same bits, the same AKS under the covers. It's just in one case, we guardrail it to have our opinionated approach. And in the other case, we don't. We trust on you to make all the decisions in that case. So let's now talk a little bit about some of the capabilities and announcements, following a little bit of what Durga just shared about what M365 has learned and what a lot of you have as well. In terms of reliability, there are a number of concerns about running at scale. Having the cluster stability match that level of scale, ensuring that the latency for your pod scheduling matches your business needs, ensuring that your network reliability is stable, and that if any case of any issues with nodes, that the service is responsive and taking care of that with both health monitoring and repair. That's exactly what AKS delivers, a fully managed control plane that auto-scales, that has auto-repair for your data plane, for your nodes, has a deeply integrated networking stack and maintains its reliability, and has full-fledged scaling for your own applications and workloads. But there's more to this. This is, again, all capabilities that are there for a long time. We keep learning. And one of the things that we've learned is that in many cases, scaling the control plane is not always right. You might have a rogue service, or rogue, air quotes there, where it might just be a service that is misbehaving and sending, for example, a large amount of inefficient list calls towards your control plane. And you might not want us to scale it. We might not want to scale it to match that, because it's actually kind of a DDoS scenario where we actually need to guard against it. So we now have Managed API Server Guard that will protect these cases, maintaining all the critical components, still being able to send calls to the API while kind of throttling these rogue clients that are doing these inefficient calls. We do that while still giving you the flexibility to control when you want to turn this on and turn this off. The other case of reliability is one that goes beyond the single cluster as well. You might have heard from Durga, typically you're going to have a number of clusters, and the reasons for it can range from different environments for your dev, tests, QA, but also for business continuity purposes across regions. And we have Fleet Manager with the intelligent workload placement capabilities to allow you to create these business continuity scenarios across different regions. You're able to essentially specify different regions in the same way that you do for topology in a single region. For example, in a single region, you would say, I want different nodes in different zones, for example, in order to spread that across. I want applications across different nodes for high availability. Fleet allows you to do that across regions. I want to have these apps spread across regions, spread across clusters evenly. This is what Fleet Management Intelligent Placement allows you to do, and then to keep that as well. With its hub cluster that is also Kubernetes, you can basically manage this at scale across the world. Next, we have capacity and fungibility. Super key. I mean, if you want to get to these levels of scale, one thing you need to have is that capacity, is that availability of SKUs and CPUs and GPUs and more. And for AKS, we try to simplify this across all aspects of your operations. From creating clusters, if you don't specify a SKU, AKS today has smart VM SKU defaults that will pick the best price to performance SKU that is readily available in the region you're picking. If you want to select your SKU, for example, you're in the portal and you're picking your specific SKU, and you just so happen to be making a not so right choice, the portal will actually tell you and say, hey, we actually recommend that you don't select that SKU in this region, go on and select this other one instead. This only happens if you make a choice that is less than desirable. On upgrade, we have the ability today to do in-place upgrades. We have the ability today to allow you to specify whether you want to surge, to do a rolling upgrade where you drain your workloads into a buffer node, or if you have enough capacity, because you might be a little bit over provisioned as that's normal to prevent spikes, you might want to use that capacity. So we have Maxen available to you, available right now in GA, to make leverage of that existing capacity, so you don't need to always surge if you don't want to. In addition, you can tweak the upgrade settings for cases where maybe your PDBs are set by a lot of different teams and maybe they're not in the best shape. You can leverage things like soak time or the drain timeout configurations to add additional confidence to that upgrade, even if it's done in place. And finally, for scaling and surging for needs of the application, we have today the ability to have a new type of node pool that you might not have heard about, which is the VM node pool type. This is a node pool that, unlike previous node pools where they were very homogeneous and uniform, you had one node pool, one SKU, you can now mix SKUs in the same node pool. Moreover, you also have node auto provision, which completely removes even the SKU picking piece of the equation. You just submit your workloads with the resources they need, and AKS provisions the best price and performance SKU that is available for you. And this is done completely automatically. Finally, you can leverage things like capacity reservations and spot placement scores to understand how to apply these operations even under constraints. Spot placement score will tell you, in case you're using spot, what are the most likely SKUs that you should use that have greater spot availability. And capacity reservations allows you to actually purchase capacity that you can spread across the different clusters. So that capacity is yours whether you use it or not. And you can use it to surge across different clusters. For example, during an upgrade, you can give that capacity to cluster A. You can then remove that capacity reservation and add it to cluster B and then use it for that upgrade in that case. This is what's already there. But one of the things we heard is that in VM pools, this new node pool type that allows for mixed SKUs, people wanted to have the exact same parity that they have on the uniform pools. And that is to not only have NAP be able to auto-scale and auto-provision, but also have autoscaler run through it and scale these different scale profiles independently. So we now have in public preview cluster autoscaler availability for this new node pool type. Next, we have, how do we leverage Azure as a whole consistent web of regions that it is and use the capacity and fungibility across the world, where not being tied to a region is often a case for running into these kinds of challenges. And so Fleet Manager, once again, allows you to leverage the capacity that is across the world. So you can have clusters in many, many different locations and use Fleet to say, I want to place this wherever the best availability and capacity is for the SKU that I want, and Fleet will place that there. And you can know immediately if this workload can be scheduled and needs to be moved to another cluster as well. What about observability? Durga mentioned this heavily in his portion, and it's super critical. In Azure, we have, through Azure Monitor, a number of baked-in capabilities and native solutions based out of open source solutions, as Brendan mentioned. In the case of Azure Monitor, you have managed Prometheus and managed Grafana. For metrics, you have container logs sending to log analytics for your logs, and you have app insights based on open source open telemetry, sending your application telemetry. This can be used to aggregate from multiple clusters and multiple sources to have this view across clusters, giving you the notions of nodes, wherever they are in the world, as well as your applications and pods, wherever cluster they belong to. And today, on the observability front, we're really happy to be GAing the embedded Grafana dashboards in the Azure portal. When we launched this, you were able to access Grafana by going into the portal, going into your cluster, and then clicking Grafana. And that would send you to the Grafana portal where you could see all the built-in dashboards and build your own. That's good, but it wasn't the experience that we wanted. So we worked throughout last year and this year to get those dashboards embedded into the Azure portal so that you don't need to navigate away. You can still customize them, run your own queries, add your own dashboards, and have all the built-in dashboards that AKS and Azure monitors create for you. We also have, as Durga mentioned, a lot of customers that have heterogeneous environments with Windows and Linux. And we want parity across it. There's a lot of workloads that require Windows, a lot of workloads, and the ecosystem upstream is really focused on Linux. So one of the things that we wanted to give parity is about health monitoring on the nodes, whether you are on Linux or Windows. So the Windows exporter is now GA. We worked a lot on its stability, and it's baked in by default in all Windows nodes on AKS. And finally, as part of our advanced container networking services, which are backed by the open source Retina project for observability that Durga mentioned, we are now announcing the public preview of container networking logs, allowing you to create essentially service maps that can represent all your services, giving you logs that allow you to troubleshoot things like DNS issues or latency very, very granularly without any additional instrumentation. The other thing that Durga mentioned that is super important is about safe rollouts and changes. So how do you do that across a whole fleet of clusters? How do you do that for your workloads as well as for configuration changes like an upgrade? AKS already provides you with a lot of capabilities such as planned maintenance, in-place upgrades, upgrade channels, as well as a lot of visibility through what happens to your upgrade, a lot of safeguards and guardrails for things like if you have a deprecated API that you're using, and that one is removed on the next upgrade, we actually will stop the upgrade before it starts. But there's also a lot of needs across clusters. So AKS and Fleet Manager have the ability for you to define a pipeline of clusters, dev, test, staging, to ensure consistency of node images and upgrades and versions across all these clusters, as well as ensure that any new change follows this pipeline. So it targets first dev, then staging, then prod, or whatever your ring strategy is. We heard also the feedback that that was great, but a lot of folks wanted more. They wanted the ability to not just soak in these different stages, but to actually create approvals for it, the same way you might have in existing pipelines in ADO or actions. So we're now announcing approval gates for update runs in Fleet Manager is now in public preview. This allows you to actively and explicitly approve moving from one environment to the other. And in my opinion, more interestingly, to hook this up to your own automation, for example, your own tests, your own runners, to then, through Event Grid, inform the approval of that gate or not block the approval of that gate. We've also heard that a lot of folks love these capabilities in terms of propagating across the different stages, but they might not want to have this in an auto-upgrade fashion. In other cases, you might have a brownfield environment where you have tons of clusters that might be in different versions today. So we are happy to announce target Kubernetes minor versions in Fleet that allows you to basically select a version, as you see on screen, and then it will propagate it through all your different clusters, one by one, leveraging all the mechanisms you mentioned before, soak time, approval gates, et cetera. So this will give you the ability to just say, okay, I want to upgrade my fleet from 132 to 133, and then this will do it automatically throughout all these stages. And finally, what about my actual workloads? So Fleet has the upgrade rollouts for your workloads too. You can have staged update strategies for your own workloads that will ensure that they are targeting first your dev environments, then your staging environments only in production, and leverage the exact same capabilities that I just mentioned for cluster configurations, but now for your workloads. So you're gonna be able to tag your clusters with the right stage that they are, and then define if you want to have this automatically, if you want to have this automated gates, if you want to have manual gates, and how do you want to propagate those across the different environments. Okay, so this is all a lot about automation, a lot about the platform teams, like our M365 platform team. But what about the users of these clusters? We want to have a platform that is engineered for productivity for those users too. And that's maybe the job of a lot of you in this room. You heard from Durga, a lot of the goals that they have is to make sure that their own developers are very productive and that they take care of a lot of the heavy burdens for things like security and configurations and more. In essence, the goals of platform engineering. You also heard them mention that they created their own UI for their developers that is based out of our open source headline project, which is the de facto Kubernetes UI as part of the Kubernetes UI SIG. That was actually created by engineers that currently work at Microsoft and primarily maintained by them. This UI was created to be a flexible, pluggable, extensible UI that you can create and customize for your own purposes. And that's what they did. But we also learned that, again, not everyone wants to create their own UI and create their own platform necessarily. So we're really happy to introduce AKS Desktop, the AKS opinionated UI that is built atop of Headlamp, the open source project. And you can still continue to customize it, and we'd love to hear from you. What do you want to see next? We're focusing primarily on developer scenarios like deploying applications, but we want to know what you want to do next. One of the scenarios that is properly baked in on desktop already is the managed namespace scenario. This is a scenario where platform administrators are going to be able to easily bootstrap scenarios, namespaces, and give them to their developers. So these namespaces will have specific access gating them, will have specific policies, and you can use them to give those environments to your developers instead of a full cluster. We've also heard that, and this is now GA, by the way, we've also heard at the same time, though, that, okay, how do I do that if I have a Fleet environment? So we're happy to announce the preview of Fleet managed namespaces. It's the exact same concept, but across the whole world. You give a developer a namespace that belongs to multiple member clusters that can be anywhere in the world. So they don't need to know that that namespace is in 3 clusters or 10 clusters or 1 cluster. That's the whole world that they see and that they deploy to via pipelines or even directly. You can now have access managed centrally for that namespace, ensuring that Dev Team 1 has access to Dev Team 1's namespace, and that namespace is spread across any amount of clusters that you decide as a platform administrator across the world. They have all the same policies, all the same labels, all the same cost associations, etc., and you can have that very granularly split. But of course, you've heard a lot about AI for productivity, and so we couldn't finish this section about having a platform that is engineered for productivity without mentioning how we're using AI to deliver some of that productivity as well. If you don't know, AKS already has an AKS agent that you can leverage. And you can leverage it with hosted models, like an OpenAI workspace, as well as your own models running, for example, on Kubernetes with 𝗦𝗽𝗀𝗀𝗀. This will give you all kinds of tasks and the ability to very easily do scenarios like troubleshooting or CRUD operations. And you can also pair it with our open source AKS MCP server that allows you to streamline how agents, like the AKS agent, does operations against your cluster. For example, using tools, tool calling like inspector gadget for deep node troubleshooting or kubectl to do all the kubectl operations that you can think of. It even can leverage the Azure Advisor. So you can really use this AI to boost the productivity of all your developers across the world, whatever the task that they're doing, as well as your operators and yourself as well. Next, we have consistent multi-cluster management. We've talked about a lot of the different tasks and challenges. The last one is really ensuring that you don't have drift across your whole fleet, that you can make sure that everything is the same or as you expect it to be, that you have consistency across. There's also an additional wrinkle. Brendan mentioned it before. Like in the case of Durga and the team, they are primarily in AKS in the cloud, but a lot of you might actually have more heterogeneous environments that span different cloud providers, might even span between cloud and edge. AKS has a full suite that allows you to run everywhere where you might need it, from cloud to the light edge with AKS Edge Essentials, to the heavy edge where you can even have the hardware procured directly through Microsoft and our partners and run AKS on Azure Local, but even you can connect any CNCF conformant cluster to Azure via Arc Connected. We've also heard your feedback. A lot of these solutions require a VM to run. That's kind of the baseline that we've done. So we're happy to announce that we're expanding our Edge and Hybrid portfolio to now support direct Linux bare metal support. You can now, if you have bare metal on-prem, you're going to be able to run AKS on it with the same capabilities and consistency as you're running it in the cloud. What about managing? All right, so now I presented you AKS in a bunch of different scenarios. How do we bring it back to this consistent management piece that we've been talking to? And that's, once again, leveraging Fleet. Fleet now supports Arc-enabled clusters, allowing you to see, you can even see different cloud providers in that picture, at a glance, any cluster, their compliance, their versions, and more, in any cloud, in any on-prem environment that you might have. You can leverage Fleet to do things like workload placement that we just discussed, BCDR, rollouts across AKS in the cloud, other providers, or any of our edge form factors. Performance is obviously super critical. No one wants to have, a Teams call lagging or anything like that. So AKS has the best story for performance in the whole package. In data plane, we have the fastest networking data plane in the cloud with Cilium and overlay. It is 40% higher throughput that you can achieve with it than if you run your own CNI. You have about 15% more throughput with overlay than any other overlay scenario that you can use anywhere in the cloud. And on the storage side, with Azure Container Storage, you have almost 6 times more performance than just regular host path. That's not just for data plane. For control plane, we have the same way where you can achieve 5K nodes and beyond much, much faster than in most other places, as well as your application and the capabilities we have to scale. We've run scenarios with real customers that needed to have to get to things such as to 50,000 nodes, as we have with some of our internal AI partners, or to 70,000 nodes across a fleet, not in the same cluster, but across a fleet of regions. And we have that as well. But also we had mission-critical customers that needed to get to 5K, the value that we have by default that you can all go to, very, very fast. So you can now get there in less than 10 minutes in AKS. We've also heard that overlay is very, very good, but that also allowed for some behaviors on just clicking next, 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 and maybe the planning was not super well done. So you might have run out of even pod IPs in an overlay network, which is not expected. But if you gave it a very small CIDR, that can happen. So we're now supporting CIDR expansion from overlay. You can just go in and update your overlay. Very excited about this. We partnered deeply with our folks, our partners in M365 for it, and that's local DNS in Azure. You have a lot of scenarios where you might have a ton of pod churn, a ton of usage against core DNS that might make it slower. And with local DNS, that is a service that is based out of the Node Local DNS project, if you know it, but instead of running as a daemon set, it runs transparently in every single node. It's an independent service. It delivers the performance you see on screen in terms of latency, but the reliability is equally astonishing. You can bypass problems such as flaky upstream servers by having serve stale and cache in each node. You can bypass problems against node-to-node communication because you now have this service running locally in every node. And you can even customize it with different plugins, forcing it to use TCP and more. Security, of course, is super important, and the challenges at scale are massive. How to deal with vulnerabilities across your whole fleet, how to ensure that you have zero trust and isolation, matching your workload requirements, how to ensure compliance across this fleet, and how to do that while maybe a lot of your security teams are ramping up in translating traditional to cloud native. In Microsoft, we have our Secure First initiative that really has 3 principles: how to be secure by design, secure by default, and have secure operations throughout our fleet and provide you with secure operations as well. In AKS, that means applying these principles across all the areas of Kubernetes, from components to control plane, our workloads, the nodes of the cluster, network, and also apply that to multi-tenancy. One thing that we've heard a lot is we love a lot of your security suite, but it maybe is a bit too embedded. So this announcement gives me a lot of joy because we've worked tirelessly in upstream to use the upstream structured auth proposal, and we're now the only cloud provider that supports via that option in structured auth upstream the ability to support external identity providers. So that allows you to go to Okta, beyond Entra ID, and more, and have the same IDP across. We've also heard the challenges of having workload identity scale beyond 20 FICs. So you're now able to do that with identity bindings. That allows you to have a single issuer for multiple clusters instead of having different issuers across, allowing you to have these identity bindings created. So controlling which identity has access to which cluster, but also then inside of each cluster, having these cluster role bindings defining who inside the cluster can use that identity as well. We're super happy to announce something that we've been working on with our Linux teams for a while, which is the 2 new operating systems. These 2 new operating systems add to our fleet of existing operating systems, which is Ubuntu, Azure Linux, and Windows. And they provide you with a container-optimized setup. You can use Flatcar if you're in multi-clouds and you want to use something that is in the CNCF and pretty vendor neutral. And if you want something that is Microsoft created and optimized for Azure, you can use Azure Linux Scar. Both of them are container optimized and immutable. We've also announced gateway API support. Coming from upstream, the next-gen Ingress APIs that facilitates multi-tenancy by having a lot more options and a lot more granular approach between platform teams and developer teams. Speaking of multi-tenancy, a lot of things that we've heard was about how do we do multi-tenancy for logs and metrics. So we're very happy to announce the general availability of multi-tenant logging in Azure Monitor Container Logs, allowing different dev teams to have access only to the logs that they should see when they're, for example, using those managed namespace options and they only have access to one single namespace. Furthermore, we're also announcing the general availability of pod sandboxing. This allows you to isolate your pods from themselves and from the node as well by using a kernel in a utility VM that is dedicated just for them. Has no workload changes whatsoever. A single line change in the YAML is enough. And we have a lot more announcements for you to check out in our security space. So check out our blogs, take a picture of the slide. We're super happy with things like granular role assignments in ACR for repos. Very happy with node resource group lockdown, egress gateway, and stealing network policies GA, as well as our deployment safeguards GA and the connection to private clusters via Cloud Shell and Bastion. Finally, cost. We made it to the end. And there's a ton that you can do there. We've now released in public preview the ability to have a configurable scheduler where you can use a more aggressive bin packing for pods. We have enabled you in Automatic to have all the system components moved away to the AKS managed plane. So you don't need to run those, achieving the lowest possible TCO in cloud for your applications in Automatic. We've also enabled for all of you a more, I would call it accurate pricing calculator scenarios because you can now add all your architecture and see the real cost, not having to put it yourself and not being aware of all the different things. Oh, I forgot this networking bit and I forgot that. You can now just put your architecture there and it will give you the full cost. And you can now export everything from cost management to your own blob storages. As a final point, I want to remind you that you are able to configure and customize all your monitoring solutions to be very optimized for cost at scale. You can do it in Azure Monitor by customizing which metrics you can do, and you can send as well as logs. You can do it in our Retina and ACNS preview already by customizing which namespaces you want to send logs and you want to filter metrics from. Finally, with Fleet, the last piece of the puzzle here, you can target different regions based on cost. So that intelligent placement is not just BCDR, capacity, and more, but also the cost that you can achieve. We hope to see that all these capabilities are going to help you, and I'm going to pass it off to Brendan to close out, and I hope to see you in future events as well.
Cool. Well, thank you, George. That was a whirlwind tour of all of the different features that we've made available in AKS, and many thanks to all of the engineers on the AKS team who've done all of that work. It's a really great set of features, and we're excited that you have the ability to access them today. So, here is the situation that we have with AKS at scale. You can have very large clusters. We're continuing to increase the number of nodes you can put into a cluster, or you can have very large environments with lots of clusters and spanning workloads across those environments and spanning fleets across multiple clouds, on-prem and beyond. And this is the AKS Everywhere path where we're truly unifying AKS in the cloud, AKS on the edge, AKS in multi-cloud environments. We're super excited about what this is going to unlock for a variety of customers who have different places that they need Kubernetes and containers. And finally, this is just the highlight reel of all of the awesome customers who are already using AKS to drive innovations throughout their business for mission-critical solutions. And it's really great to see that as well. We've heard about M365 running at scale. These are all a bunch of other companies you probably have heard of running at scale on AKS. And here are the related sessions and resources. Highly encourage you to check them out. Thank you so much for listening. Thank you to Durga and George for helping with the presentation. Have a great Ignite.